Kia ora. I'm going to go through practice question 4. This is from pages 87 and 88. Okay, first of all, sketch the gradient function f dash of x of the function f of x below. These are a lot better if one of them is above the other. Doing it side by side is kind of annoying. Anyway, what do I notice? I notice that this is a negative cubic. Now, if this is a negative cubic, the result is going to be a negative parabola. Now, another thing that I think is quite important. This is a turning point. This is a turning point. They're very important. TP. TP. Now, those turning points are going to correspond over here to the intersections of the parabola. So this is where it's kind of an issue that it's a little bit far away, so we maybe have a way of finding out how far away. Where is it? It's on like the first coil of the spring. Nah, you don't have to be that accurate, to be honest. And then this one here is a little bit further over, so maybe we'll go like here. So those are the points that it's going to intersect, right? And it's a negative parabola, so we want to have like the vertex maybe somewhere around about here. Doesn't matter too much. All they care about is if you pass through here and that you get the shape of the derivative correct. To be honest, that's a pretty ugly parabola, but yeah, that will get you full marks. Yeah, cool. Find the coordinates of the turning point of the function. Okay, this is highest power is squared, so I know it's a positive parabola. So it's going to be a turning point like that. So all we need to do to find a turning point is get the derivative. So it's going to be 10x minus 24, and then we just set that equal to 0. 24 equals 10x, x equals 24 over 10. Let's get a calculator up, eh? Oh, no, I don't want that piece of jank. I don't want that piece of jank. The thing is, by the time you get the calculator out, you've done it in your head, which is ideal, which is 2.4. Ooh, look at this. Coordinates. They don't want just a value, so I know it's when x equals 2.4. Now what am I going to need to do this? So I just substitute it back into here? No. I need to substitute it back into the original function. Now remember, this function g of x, right, we looked at the derivative. We looked at the derivative because this turning point corresponds to where g of x crosses over, right? This is going to be our g of x, so that's how we found out. We said when is that equal to 0, that found us the point, right? So that gave us where the turning point was. But then to find out the y coordinate, we need to substitute it back into the original function. So we're going to have to do g of 2.4 equals 5 times 2.4 squared minus 24. Oh shucks, can I fit it in here? 2.4 plus 3. Yes, just. Okay. We will now use our calculator. I wonder if we can do this all on... I need to click menu here. Okay, let's try. 5, 2.4 power of 2 minus... Oh, I don't really need to do that. 24, 2.4 plus 3. Did I do that correctly? Negative 25.8. Does that make sense? Yeah, because that's going to be a really big negative number. Yep, looks good to me. Equals negative 25.8. I mean, it's possible that I make a mistake on these, and I probably won't address it at the time, but it will make it more interesting for you, trying to find out where I made my mistake. Yeah, so now we've got the coordinates of the turning point. Okay. Alison bought a second-hand car for 13 grand. The rate at which its value changes is given by this. The V represents the car value in dollars and T represents time in years. Calculate the value of the car after 5 years. So we've got a rate of change of the car value. We don't have the actual car value. We have how much the car value is changing. So we're going to need to anti-differentiate that. So let's do that. We'll just go for straight up V equals negative 600, and we are anti-differentiating in regard to t. So I've increased the power of t by 1 here, and then it's going to be minus 12t squared. Then don't forget your constant of integration. Now, the value of the car is this formula, but we know that when at t equals 0, right, when the car's just purchased second hand, we know that v equals 13 grand, right? So we can do a substitution to find c. And in fact, it's kind of pointless me doing this because I know it's going to be 0 minus 0 plus 1300. Oops, shucks, my bad. Plus c, and it just shows you that c is 1300, so it's kind of a bit straightforward. But you don't need to show all of this working, I'm just showing you why. After you do these a lot though, you'll start to realize that if they've got a formula like this, where there's t involved in every step, then you know that that value just becomes c. Okay, plus 1300, and then they want to know 5 years. V after 5 years is negative 600, 5 minus 12, 5 plus 13. Okay, calculator. Negative 600 times 5 minus 12 times 5 squared plus 13 grand. Yes, looks like the sort of value of a car after 5 years. It shows some, probably depreciate faster because she's going to crash it, let's be honest. Although Allison, who knows. Can't stereotype too much. Yeah, it looks good to me. Oh, no, need units. So, and it might be worth saying at t equals 5 here, just to make it clear what you're actually doing. Okay, moving on. We're halfway now, but the questions actually should get a bit harder. A landscaper is constructing a garden, which is a 1 meter wall on one side. Its height is given. So 1 meter by Blair, where h represents the height in meters, but I know that it's 1 meter. Or maybe that's horizontal. And x represents the distance in meters from the wall, so that the garden rises to a maximum 10 meters from the wall. I don't know. I to be honest, you don't really need to understand these too much. Like, I know that if I'm finding a maximum, right, and I look at this and I can see it's a negative parabola because the highest power is squared and it's negative, I know that the maximum is just going to be there. So you don't actually need to understand these questions too much. Like, I'm trying to picture this wall in my head, and I just don't care. So we're just going to go h dash. Equals, we get rid of that 1, 0.4 minus x over 25, right? And then we're going to maximize that by setting that equal to 0. 0.4 minus x over 25. And then we'll flag that over here. X over 25 equals negative, oh sorry, just positive 0.4. X equals 25 times 0.4. That's got to be something nice. Come on, brain. 25 over 4, 12.5, 6.25, 62.5? Oh, what am I doing wrong here? 6.25. Does that make sense? Yeah, I reckon it's 6.25. Don't trust my brain right now. 0.4 times 25. Shucks. What did I do wrong there? Man. So we use calculators, people. What did I do wrong there? 25 times 0.4. What I did was I divided 25 by 4. And I got 12.5. 6.25. And now I should be able to times it by 10. Oh. I don't know. Yeah, my brain's sketching out. Oh well. Show that the garden rises to a maximum 10 meters from the wall. Well, there you go. X equals 10 meters. I could write something about that's... Nah, that's fine. Okay, next one. The curve of f of x equals -2 blah, blah, blah. Has a tangent with a gradient of 3 at the point 1, 10. Find the coordinates of the point on the curve x equals 1. Okay, these ones are a little bit nasty because you can't, it's hard to visualize what's happening, so I sort of like to make it up. So it's a negative cubic, right, and there's some point where the gradient would be 3. Well, where would the gradient be 3? It could either, it's probably 3 around about, it'll be inside here somewhere, right? So let's just make up a point. It's not necessarily going to be true, it's just our way of us visualizing it. So there's a point here at 110, but it may not be true. Find the coordinates of the point on the curve x equals -1. And then there's going to be another point later on at x equals -1, and they want us to find that later on. So it's like a couple of steps, which makes it kind of tricky to think about. I've sort of just layered complexity on you, right? Okay, so what we're going to do is first we're going to differentiate. If you're not differentiating or integrating, you're probably doing something wrong, right? Or it's just a step in a question. Okay, first derivative, -6x to the power 2. And then how would we differentiate this? Well, a is just a number, right? So if it's a number x, all that happens is it just becomes that number without the x next to it, right? The b, on the other hand, doesn't have an x, so it's actually just going to go away. So we can find the derivative of this. Now, has a tangent with a gradient of 3. So when is the gradient 3 now? Well, the gradient is 3. Yeah, -6x squared plus a. This is when the gradient is 3, but we can't solve for that because we've got 2 unknowns so far. Oh, but we know it's at the point 110. Boom. So we can just substitute x as 1 in here, and then we find a, right? 3 equals -6, and then when x is 1, that's when that is the gradient. So now we've got only one unknown. Sweet. 3 equals -6 plus a, therefore a equals 9. Sweet. So we've got a. We still need to find b. Oh, well, we can do that just by substituting, because we've got this 110, right? Let's just substitute that in there with our new found a. So f of x is 10, right? And then we just chuck everything else we know in here, -2, and then this is at the point 1 plus, and now we know what a is, 9 times, we know 1, and now we've only got one unknown here. Boom. 10 equals -2 plus 9 plus b. -2 plus 9 is 7, and then that becomes 3 equals b. So we've now got a and b, so we've got a function, right? Find the coordinates of the point on the curve where x equals 1. This is not really a calculus question. No, it's got some nice elements of a calculus question, I guess. Yeah, it's nice. It's a nice question. Okay, bx equals -1. Okay, so f of -1 equals, and now let's chuck in what we know, 2 -1 cubed plus, we now know what a is, 9 times -1, we now know what b is, plus 3. So we can just solve this. -1, so it becomes a +2, it becomes a -9 plus 3, equals -7, -4. Find the coordinates of the point on the curve x equals 1. So the coordinates, this happens at -1, 4. Find the coordinates of the point on the curve. Yeah, it looks good to me. That looks like our picture was pretty good. Our picture was fairly accurate. Like, the picture came out, like, it actually makes sense. If you're going across -1, you go down, it's sort of a little bit out of proportion, but you got the right idea just from a little guess, just to help us out. Okay, final question. A car starts from rest. Boom. That's a massive clue. right? A car starts from rest. We now know that the acceleration is 0 at t equals 0. We know velocity is 0 at t equals 0. Oh, actually, we don't know about the acceleration. Anyway. Oh yeah, look at that. The acceleration is actually 1.6 at the start. My bad. Acceleration, t seconds after it starts given by there. How far does it go in the first 20 seconds? Look at this. How far? That's an s of t. So we start off with an a of t, right? And then we're going to have to build that into a v of t, and then we're going to have to build that into s of t, right? So all of these steps are going to be anti-diff. I can't wait until you guys are allowed to start calling it integration like it actually is, but for now, anti-diff. Okay, so let's do it. A of t, oh, I'm writing this out pointlessly, 1/20t. So therefore, v of t equals 1.6t minus 1/40t squared. I added 1 to the power and then divided by the new power, and then plus c, but we know velocity at t equals 1, t equals 0 is 0, so c equals 0. Boom. So we can get rid of that. I just sort of gave you guys some sort of reasoning. Okay, now let's anti-differentiate up to s of t. S of t equals 0.8 t squared minus 1/120. Man, this is getting, and then plus k. But we also know it starts from rest, and so therefore distance at t equals 0 is 0, so k equals 0. So then we can get rid of that one. So now we've got a formula for s of t, and then we just chuck a 20 in for that t. S of 20 equals 0.8 20 squared minus 1/120 20 cubed. What is 20 cubed? Oh yeah, that's actually relevant as heck. 20 cubed is 8 times 100? Or is it times 1,000? Times 1,000, I guess. 8,000. My mental arithmetic's rubbish today. Big ass. Okay, let's just type it all in. 0.8 20 squared minus, oh, you gotta be a little bit careful with these ones. 1/, oh, it doesn't actually going to do division. Oh, I'm worried now. No, it should be fine. Okay, 253.333, and what are we in? Meters. We've got an M there. So yeah, if our acceleration started off as meters per second squared, then the velocity is going to be meters per second, and then we therefore know that distance is going to be in meters. Okay, so I need to write meters here. Gotta have units. Should we do a little check? See if I actually got these right? Yeah, why not? You guys can stop watching the video now if you don't want to see the check. Okay. Check with your teacher. Dang it! Okay, so what did I get? Negative 25.8. Yes. 9,700. Yes. What did I get for here? 10 meters. Ooh. A, B, C, D. X equals 10 meters. Ugh, I don't know. This one here, f of -1 equals -4. Ooh. Yes, -1, -4. Cool. And then the final one is 253.3. Yep, that's what we got. Cool. So yeah, that's the full walkthrough of practice question 4 from the Walkermaths calculus book.